The term black oil is frequently cited in reservoir simulation studies as various volatile components are collectively considered to be a single gas phase due to the relatively low volatility of crude encountered in many reservoirs. It is used here to categorize oil reservoirs that fall between the volatile and heavy oil reservoirs in terms of the specific gravity of crude. The gravity range of typical crude would be 38 degrees to 22.3 degrees API, relative density 0.83 to 0.92, approximately. The abundance of intermediate hydrocarbons is the typical characteristic of black oils. The color of black oils is variable from green to black. For both volatile oil and black oil, the initial reservoir temperature is below the critical point, and the fluid is therefore a liquid in the reservoir. As the pressure drops, the bubble point is eventually reached, and the first bubble of gas is released from the liquid. The composition of this gas will be made up of the more volatile components of the mixture. Both volatile oils and black oils will liberate gas in the separators, whose conditions of pressure and temperature are well inside the two-phase envelope. A volatile oil contains a relatively large fraction of lighter and intermediate components, which vaporize easily. With a small drop in pressure below the bubble point, the relative amount of liquid to gas in the two-phase mixture drops rapidly, as shown in the phase diagram by the wide spacing of the isovol lines. At reservoir pressures below the bubble point, gas is released in the reservoir and is known as solution gas, since above the bubble point, this gas was contained in solution. Some of this liberated gas will flow towards the producing wells, whilst some will remain in the reservoir and migrate towards the crest of the structure to form a secondary gas cap. Black oils are a common category of reservoir fluids and are similar to volatile oils in behavior, except that they contain a lower fraction of volatile components and therefore require a much larger pressure drop below the bubble point before significant volumes of gas are released from solution. This is reflected by the position of the isovol lines in the phase diagram, where the lines of low liquid percentage are grouped around the dew point line. Volatile oils are known as high shrinkage oils because they liberate relatively large amounts of gas either in the reservoir or the separators, leaving relatively smaller amounts of stabilized oil compared to black oils, also called low shrinkage oils. When the pressure of a volatile oil or black oil reservoir is above the bubble point, we refer to the oil as undersaturated. When the pressure is at the bubble point, we refer to it as saturated oil, since if any more gas were added to the system, it could not be dissolved in the oil. The bubble point is therefore the saturation pressure for the reservoir fluid. An oil reservoir that exists at initial conditions with an overlying gas cap must be at the bubble point pressure at the interface between the gas and the oil, the gas-oil contact, GOC. Gas existing in an initial gas cap is called free gas, whilst the gas in solution in the oil is called dissolved or solution gas. If you want to learn more about black oil reservoir, you could do so in my book, Economics of Petroleum Reservoirs, which is published on Amazon. Check it out at the link in the description. Please take a second to hit the like button, hit the subscribe button, and do not forget to hit the notification bell. Thank you for watching, and goodbye.